So this is a sum in the physics numerical. That you can see there is a graph here. In the graph you can see the y-axis represents the velocity and the x-axis represents the time. So here is a question that has asked that find the distance and the displacement first in first 4 seconds, next 5 seconds, and in 13 seconds. So what we are going to do here, we will partition this graph into 3 different sections. That we can see here that some moving object has started with velocity 0, then it has peaked its velocity till 15 meters per second. Then again it has reduced its velocity to 0 in this duration of 4 seconds, 1 second. And so in the 4th second the velocity again became 0, and then the velocity became negative. In next 1 second the velocity became minus 5 meters per second. The velocity became negative when the direction changes. So if we fix the direction in a particular direction, then we take the velocity as positive. When the direction change, then we take the velocity as a negative velocity. So let's find out the distance covered by that moving particle in the different sections. So for this section, this is a triangle. So in this we can find out the distance will be, as it's a triangle, so half into base into height. So half into the base we can see is 4, into height we can see that is 15. So half into base into height we can find out it is coming 30 meter. 30 meter distance is covered in the first section. So this is for the first section. In the second section we can find out the velocity became minus 5 meter per second in the 5th second. Then the velocity was fixed till 8th second. Then again the velocity was increasing till 0. Means it was increasing to 0 meter per second in the next 1 second. So here it is a triangle, so trapezium. So in this trapezium we can find out the area which will give me the distance in this place. So the formula for finding the area for trapezium of that is half into sum of the parallel side. So here the sum, if we do, the parallel sides are here 4 to 9, so it is 5 plus. In this case it is from 5 to 8, so it is 1 2 3, so it's 3, so 5 plus 3 into the height. The height we can see as it is 0, so 0 to 5, so it is 5. So if you calculate this will give you 8. So if I cancel the whole as with this, so as if there is a shortage of space, I'm doing in the same step, so it is giving me 20 meter. So the distance covered from 4 seconds to 9 seconds is 20 meter. Come to the last phase, that is also trapezium. So for this case the distance, if we find out with the help of the same formula, that is half into the sum of the parallel side. So as we can see, this will give you 2. So 2 plus the bottom part is 4. So 2 plus 4 into the height that we can see here, that is also coming to the same alignment. So it's 15. So if we cancel, it will give you 6. So 3 are, so 3 15 are 45 meter. So now if we look into the whole sum, so the in first second the distance, if you ask, so that will be 30 seconds. So and the displacement, if you say in the first 4 seconds, so that will be like 30 seconds, 30 meter only, because there is no negative direction of the particle is going on. So now in the next 5 seconds also, if you find out that the distance covered by the particle we have got here, that is 20 meter, and the whole 13 seconds, if you find out the total distance covered by the particle, you have to add up all this. So it is like 30 plus 20 plus 45 whole meter. So it will give you 105 meter. That is the whole distance covered by the moving particle. Now if you are trying to find out the displacement of the particle in the throughout 13 seconds in the whole journey, so what you have to do, you have to find out the net displacement of the particle. So as it is a positive movement, so we will take this 30 as 40 as plus. But as this movement was a opposite directional movement of that moving particle, so the second phase we will take as the negative displacement for that moving particle. So 20 will be minus, and the last one was again a positive displacement, so that will be also a plus. So if you calculate it in this manner, that is 30 minus 20 plus 45, which will give you the net displacement of that moving particle. So it will give you here 10, and so it is 55 meter. So that will be the answer of the part C of this question. That is the displacement. Okay, and I hope all of you have understood.